So hopefully everything's going smooth compared to last year. I just want to give you a brief disclaimer. It is very early in the morning. As you can see, it is very dark outside. So my apologies if my voice is a bit low. I don't want to wake up my neighbors, but I will try to make sure that I cover everything that I want to. And if we do have enough time, I'll try to see if I can cover a bit more. As always, if you have any questions at all, let me know. I have the chat open on the other side of my screen. If you have any questions, let me know. Obviously, I wouldn't have all the answers, but I will try and answer any questions that I can. If I'm not sure of any specific question, then I will try to reach out to my colleagues in the field and see if I can come back with a response. And obviously, any response that I get, I'll share with Kumanan sir, and he would be able to give you that information. Okay. Right. So this is. Hopefully, again, you can see the slides okay. If not, just let me know. But again, a quick introduction about myself. My name is Swaminathan. I am currently employed as a senior security testing analyst at Bank of Ireland. I have a little over 3 years of experience in information security and cybersecurity. That's everything I've known. I did my master's right after I graduated from computer engineering. Again, I did my master's in digital investigation and forensic computing at University College Dublin in Ireland, so here. And I've also done my certified ethical hacking and CHFI, which is certified hacking forensic investigation. I did not take the certification for the second one because I did my master's, so I didn't really think that was really a thing that was needed. So there's that. Quick overview of today's schedule. We have, I have quite a few slides, as you can see, but I will try to see if I can cover as much as possible. But this is just the schedule for today. 9 to 10:30. It is going to be forensic technology and systems and understanding computer investigation. Quick 15-minute break after that. And session 2 would be processing crime and incident scenes. So for this section, looking at the schedule and the actual syllabus, I did notice that a few of the topics were being shared with a few of the other speakers as well. So I call out certain topics which I won't go too much into detail. Hopefully the other resource personnel would be covering them in depth, so I don't want to make that redundant. So I will go through them at a high level, but not too in depth. With that, first topic, forensic technology and systems. Also, quick one. Could you just let me know if you're able to hear me okay? If you can just type yes or no in the chat, that'll just give me a thumbs up to proceed. Yes. Okay, excellent. Thank you very much. Cool. Forensic technology and systems. I'll start off with the basics and then we can go deeper, if that's okay with everyone. I know yesterday's session covered a bit of forensic investigation. So I'll glance through this really quick just for anybody who may not have attended it yesterday. Digital forensics and digital forensics. Qu'est-ce que c'est? What is it? Forensics, it's a branch of science which involves collection, preservation, and analysis of scientific evidence, usually carried out over the course of an investigation. Everybody's seen CSI shows, CSI Miami, New York, blah, 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 where investigation basically forms the backbone of, or forensic investigation forms the backbone of any crime scene investigation. Usually you don't catch the perpetrator immediately. There's some type of evidence gathering that's done. You go to the crime scene, you look at whatever information is available, you make a record of everything, you collect everything, go back to your lab, do a bit of cinema magic, and at the end of the day, you find the evidence and you catch the bad guy. In general, yes, that is what forensic investigation is. Obviously, there's little more to it than finding everything by the end of the day. Usually digital forensic investigation and normal forensic investigation takes a long time, depending on what kind of evidence you're looking at. But that's the gist of it. So, sorry, say again, sir. Did you need anything? No, cool. I'm just going to see if I can drop that there just to save some bandwidth. Digital forensics is basically just the evolution, the next stage of the standard forensics. So instead of looking at DNA evidence and hair strands and looking for evidence on that, you're doing it on computer systems and well, everything that has to do with today's modern technology. So it's the natural evolution of what forensics was, more custom made for today's modern world. So what is digital forensics? It is by definition the process of identifying, preserving, analyzing, and presenting digital evidence for the purposes of presenting it to a court. So when I say presenting digital evidence, that is mostly referring to presenting information to a justice system where an investigator is not somebody who determines if a person is guilty or not, but an investigator is somebody who will present facts to a justice system like the court and let them determine, based off of the evidence that you've given, if a person is guilty or not. And here, I've expanded on it a little bit more. The aim of digital forensic investigation is to identify the evidence quickly, estimate the potential impact of the malicious activity on the victim, and assess the intent and identity of the perpetrator. And again, just to clarify, when I say perpetrator, this is the person who actually has either attacked your system or has taken information from your system using a computer system or computer technology. It could also not only be used to identify who the actual attacker was. In certain cases, you could also use digital forensic investigation to exonerate a defendant. And when I say exonerate, it means to prove that somebody is innocent. Because if, just for the sake of example, if a person is being accused of stealing data by an employee who doesn't like them very much, that person can't defend themselves. But as a digital forensic investigator, what you can do is take all the information that you have from that person, from their system, from their network logs, from every single system that this person has had access to, comb through all that data and find out if this person actually did extract confidential information, for example, from an organization or from a law enforcement agency. If we can find no evidence suggesting that this person had actually stolen data, then there's nothing to prove that this person is guilty, which means by default, they are innocent. So it could also be used in that kind of scenario instead of just finding out who did something wrong. It could also, well, potentially save someone from going to jail incorrectly. So that is also something that digital forensics can be used for. Can I make presentation full screen? Yes, I can. I just am not sure. Audience Q&A, speak notes. Okay, here we go. Let me know if you can see that, because I have only a single monitor set up at the moment, so I'm not sure if it's showing up as full screen or not.
Yes, now it's full screen.
Okay,
thank you.
Thank you very much. Okay, all right. Next, there we go. I'm really sorry, give me just a second. I'm just trying to figure something out here. Okay. Okay, cool. Sorry about that. Right. So now that we've covered the basis of, or what the basics of digital forensics is, let's dive a little bit further into forensic technology. Forensic technology is a vast topic. And since we have only 1.5 hours to cover for this session, and obviously we have one more session coming up, I have tried to give you a general idea of what things are. I tried to give as much information as I can, but obviously, as usual, if you have any questions, do let me know. I will try to address it as much as possible. If I'm not entirely sure of any specific response, I will come back with that response to you. Right. So, as I said, forensic technology, it's massive. 10 years ago, forensic technology was basically just, oh yeah, it's localhost. It's just a PC that you have or server that you have. You extract data from it and then do forensics on it, and that was it. Or not, 15 years ago, I guess. But now it's branched off so much just because of how explosive technological advancement has been. I've broken down the different types of forensics that you do as an investigator in that slide. So as you can see, there's localhost forensics, which is your standard PC, Mac type of forensics. Cloud forensics, which is an all-encompassing forensic investigation that you would do. Mobile forensics, again, everybody has at least one mobile device, if not more. Network forensics, it could be also referred to as wireless forensics, because networks are sometimes also used to refer to the infrastructure of an organization. So the number of servers that an organization would have, switches, routers, and all of that would also be referred to as a network. So network/wireless forensics, I will go into more detail for that specific topic a little later on. Malware forensics, you have your different types of viruses, you have your worms, your rootkits, your ransomwares, and all the good stuff. Email forensics, if a crime was carried out using an email service, then we use email forensics to do that. I feel like email forensics would be the most straightforward investigation that can be carried out. And again, I can go over that in a high level later on. And then there's memory forensics, which is volatile memory forensics, which is your RAM, your system memory. So those are the types of forensic assessments that can be done, and they are like I've given a very high level description here. I'll go further into detail in the next slide. So we'll just glance over this for a quick second. Local forensics, it's usually your hard disks, your SSDs, your flash memories, CDs, DVDs, Blu-rays, anything that you can hold as a physical media. Cloud forensics, there's plenty of cloud services available: AWS, Azure, IBM, Google Cloud, Salesforce, Adobe, all that good stuff. Cloud forensics also is heavily dependent on what kind of cloud model that is being used. So private, public, hybrid. There's also community model, which I haven't included here because I'm not too aware of what kind of investigation can be carried out on community model. I would assume it's similar to public, but just fair disclaimer, I haven't included that in here. Mobile forensics, again, Android and iOS, majority of the market share is held by them, so I've included them here. And then there's niche OSs, which are becoming more and more obsolete. So BlackBerry, obviously, as many of you may know, they no longer support their mobile operating systems, which is a shame because they were really secure. And the Windows Mobile, same thing. Microsoft didn't see any profit, so they kind of stopped supporting it. And then there's a few other tiny mobile operators here or mobile manufacturers here and there who still make their own versions, but it's not really that popular. Like maybe 1% of the market would be like other vendors, but other than that, it's very minimal. Right. Before I get into the actual types of forensic investigations that can be done, I want to talk a little bit about the forensic tools themselves. Fair disclaimer, I won't be going too much into depth because I looked at the schedule, and I believe Mr. Shakti will be covering that in the afternoon session, I believe session 3. So I'm not going to cover that here. I don't want to introduce redundancy as much as possible. So what I've done here is just given you a very high level overview of what type of softwares and hardwares are used by a standard digital investigator. My favorite ones are Autopsy, FTK, and Santoku. Autopsy is basically just think of it as a command line browser almost. So once you have a image, you could essentially load it onto Autopsy, and you can browse through the contents of a hard disk, just like you would browse through a file on Windows Explorer, for example. It's a really good tool. Obviously, it's open source, which is always good. It's free, so they haven't really exploited the open source part of it. It's constantly supported by the development team. They constantly introduce fixes. They constantly update software. So really solid. So if anybody wants to get into forensic investigation, I would definitely recommend Autopsy as the first tool that that you start getting into. It's really good. It's user friendly, and obviously there's plenty of tutorials and everything out there to use the application. SleuthKit is by the same company, but it's a command line tool instead of a GUI based. So it's a little more hands-on. You have to be willing to look into the actual help menu, look at the commands, blah blah blah. But that's really it. There's both options for people who prefer GUI over command line and vice versa. So it's really up to you. NK's NextWays, they are paid professional versions of Autopsy. They are mostly used by law enforcement agencies. I know that a friend of mine who works for the German government, she and her colleagues use NKs basically on a daily basis. So it's a really powerful tool. Very expensive, but based off of my usage, it really is a step above the rest. X-Ways, similar situation. It's just by a different manufacturer, but again, really powerful, really useful. It also helps you do case management in a really efficient way. So if you want to take a look at some of these applications, they are out there, but again, NKs and X-Ways are paid, so just a fair warning. FTK Imager, it's just used to it's a forensic toolkit imager, which is used to get an image or a clone of a hard disk. That's basically it. You could use it to clone your USB drive, your hard disk, your mobile phone if you wanted to. It does what it says. It's fairly it's very reliable. It's fairly small application. It's free. It's open source. So if you want to again start looking into forensics, I would definitely point you towards that. Volatility, I haven't used too much of it, but from what I've read, it is a volatile memory forensic tool, so it's more dedicated towards RAM assessments, so taking memory dumps and starting to cont with that information. Not too familiar with that one, but I've been told that it is good. And then Santoku, which is an operating system which is more focused on mobile forensics. I've used Santoku in the past. In fact, I used it for my project when I did my master's. Santoku was really helpful there. It's again free. It's a Linux distribution, so it's a well-maintained, well-updated distribution. So if you have a VM that you can spin up, I would also definitely recommend spinning up Santoku, just playing around with the different applications that's available and see what suits you. Hardware, write blockers, which I will go a little bit more into detail a little later on. They're very useful. They are the best friend of any forensic investigator. So Mr. Shaktivel will probably cover that more in depth towards his session. But write blockers, keep that in mind. That will come up a few times in the coming slides. Forensic workstations, these are custom-made PCs or laptops, which would have write blockers and everything pre-installed on them. And they're really powerful, obviously, because forensic imaging and forensic processing takes a lot of power, not just battery life, but also CPU power is drawn significantly by some of these applications, because at the end of the day, you are working with files which end up upwards of 500 gigs all the way to 2 terabytes, depending on whichever file you're imaging. So they do need to be powerful, and there's a few bits and pieces which are custom built into the actual machines themselves, which are made by certain organizations. So those, again, similar to right blockers, one of the best friends of any forensic investigator. Faraday bags and cages, pretty cool piece of tech, which is basically a tiny bag which is surrounded by copper coils, which would generate a magnetic field, or I can't remember if it's a magnetic field or an electromagnetic field, but it would block out any radio signals from going in or out. That's mostly used for mobile forensics, not forensics itself, but mobile acquisition. So if you have a mobile device in hand, you usually have a Faraday cage brought along so that you don't alter the content of the phone. Evidence containers, sorry, equally as important as everything above, because if you mislabel your evidence will be thrown out of court. Even if your evidence actually shows that someone is guilty, if the evidence isn't handled properly, it will be thrown out of court. It will not be admissible evidence, and you will end up losing the case for yourself and your potential clients. And obviously, logs. I don't know why I had it on their hardware, but logs are also important. Next slide. Before we go any further, yes, similar to the right blocker point that I brought up previously, this is something that is going to be a repeating point that I'm going to be emphasizing on. So the first point is any peripheral device, be it a USB keyboard, a mouse, a monitor, any flash drive that you plugged in, any peripheral that you connect to your machine, be it your laptop, your desktop, your phone, could be anything, any system that has that runs on an operating system and has a volatile memory. Once you connect a peripheral in, it will change the contents of the system's memory. So that is something that needs to be kept in mind. And it doesn't have to be something as drastic as, oh, I've copied a file from one drive to the other, I've deleted something. It doesn't have to be that drastic. It would be as simple as moving your mouse or pressing the Windows key just to bring up the start menu. That would also change the content of the memory and potentially the logs, because you did an action at a certain time on a machine, on a target machine, which means you have now changed the contents of that evidence. And as you know, certain machines may have logging enabled, which would obviously capture this information, which means, again, you have added on to that machine other than what is supposed to actually be there. So these 2 points, critical for forensic investigation. I would recommend keeping this in mind, because this is going to be a repeating point as we move into the next slides. The next one. Now that we've gone over the basics, we now start going into the actual forensic tech. Disk forensics, this has a bunch of different names. Computer forensics, disk forensics, local host forensics. I've come across a few more here and there, but basically it has to do with your physical media, your physical storage media. Again, I've covered that here. Typically involves storage media like HDD, hard disk drives, which is magnetic disks, which you would see in your traditional systems, your traditional computers. I'm pretty sure most of the lab equipment at the college would have HDDs installed in them, from memory at least. SSDs, which are solid state drives, which is basically the better version of an HDD. They use NAND flash memory, I believe. There's no moving parts. It's all read-write by electronic means instead of a actual actuator arm and magnetism. So they are efficient, faster, but also a forensic investigator's nightmare. So SSDs, CDs, CD, DVD, Blu-ray, anything that is a compact disc format. Flash drives, and when I say flash drives, I don't mean just the USBs that we use, but also flash drives that are on mobile phones. A lot of the phones, I'm not sure if many of you know here, but a lot of the mobile phones are using flash drives, just different implementations of them, but they are still flash drives. So that's there as well. Sorry, just lost the screen. There we go. Even though these are all different types of storage media, the way in which the data is handled is depend on the file system format that the disk operates on. This is also dependent on the operating system itself, because these, I'm sure many of you will be familiar with, but HFS and then HFS Plus, they are used by Mac OS. So Apple's desktop operating systems would use HFS. So they wouldn't be the same as NTFS, FAT, exFAT that is used by Windows. Obviously, there are older versions, but older versions of file formats that was used by Windows. I think Windows NT and before had FAT32, and then one more format before that I forget. But the more frequent ones would be these are the ones that you would usually see. So just keep that in mind. And I think if I recall correctly, there's also another session coming up, I want to say tomorrow, which deals with looking at actual forensic data and validating that. So I would assume this is captured there as well. To go into a bit more depth into hard disk drives and their implication with forensic investigation, hard disk usually has hard disk data writing is usually done on disk sectors, and obviously I've tried to bring up a diagram that is as I guess accurate as possible. Obviously I couldn't find one that is more in depth, but this should hopefully give people a good understanding of how the disk sector looks like, and and how the actuator arm starts writing data between them. And the way data is recorded on hard disks is by magnetization. So by magnetization and demagnetization, it's either a 1 or 0 is recorded on a disk sector, and that essentially is how data is recorded on hard disk drives. I'm not going to go too depth into that because, to be honest with you, it's been a long time since I've studied the in-depth workings of a HDD, so I don't want to say anything that might end up being wrong. So I'll just give that a quick high-level glance, and I'll move on to the forensic side of it. So on hard disk drive, if you're on your computer right now, and if you have a file on your machine, if you hit delete on that file, to you, it would show as if it's deleted. Yes, it goes into the recycle bin. You go to the recycle bin, you hit empty recycle bin, that's it. According to the user, that file is no longer existent. It's gone. You can't undelete it. But that's not entirely the case. So if you look at the second point here, if a user deletes a piece of data, the file appears deleted for the user in the UI, which is the user interface, but the actual data is still stored in the HDD. So what that means is, in theory, if you have the right tool, you could recover that deleted file, even if you've emptied your recycle bin and everything. And even if you've restarted your system a couple of times, you could still, in theory, recover the data, even if you have no GUI representation of it. This data is marked for deletion by the controller, and the controller is a firmware that comes with every hard disk. And that is what dictates how the actuator arm records the data. That is what is used to interact with the host OS. So if your hard disk is installed on a Windows machine, then that controller is what talks with the Windows OS, and it acts as an intermediary between the hard disk hardware and the actual operating system itself. So the controller marks this data for deletion, and it's kept there basically until there's new data to be written. It may not necessarily be that this data is written immediately after new data is ready to be written. It may be written immediately. It may be overwritten a month later, a year later, depends on how frequently that hard disk is used. So if you use the desktop or hard disk on an everyday basis, and if you do a lot of read-write operations, then good chance that that deleted file, that marked for deletion file, was overwritten by any new data that you introduce. But if let's say your computer usage is sorry, okay, my apologies, something just popped up on the screen. There we go. Yeah, but if you use it on an everyday basis, good chance that that data was overwritten once or twice, depending on, again, frequency of usage. But if you only use the system once a month, twice a month, good chance that it may not have been overwritten. So in this case, if you take an image, and when I say an image, I mean a copy of that hard disk, and if you put that through a tool like Autopsy or Encase or Xways, you would be able to recover the file sometimes or most times in its entirety. So you wouldn't get bits and pieces of information. You would get the full file. So if you deleted a Word document with, I don't know, 12,000 words, for example, if you delete that file, take an image of your hard disk, put that on Autopsy, you will, in theory, be able to get that file back with all 12,000 words. So that is full recovery. Partial recovery is when parts of the deleted data were overwritten, and then part of it is still there, which it's not completely useful because it's only partial information. So you wouldn't be able to use that as full evidence, but you would be able to use that partial information as supporting evidence for any other evidence that you may have that you could essentially supplement with this information. So that's a quick overview on HDDs and how they work, what kind of implications they have with respect to forensic investigations. SSDs, oh boy. SSDs, again, it's basically a more beefier version of HDDs. There's a lot of differences in the way they operate. Obviously, their physical hardware itself is different. HDDs use magnetic disks to actually read and write data with an actuator arm. But for SSDs, everything is purely electronic. There's no moving parts, which also means they're highly efficient. Their read and write is incredibly fast. I'm pretty sure the fastest HDDs nowadays, or SSDs nowadays, go for 10 gigabyte per second of read, or 10 gigabyte per second of read, or something along those lines, which is way faster than any HDD would ever be able to do because there's no moving parts. It's all electronic. Again, similar to the previous one, I've given you a high-level description of how data is handled in SSDs, and this diagram hopefully gives you a general idea of how data is stored and managed. Again, think of there being a controller which acts as an interface between the OS and the actual hardware itself. That controller would basically control where a piece of information is written. So just to give you an idea, so data in SSD are written in pages, which is the green rectangle in the diagram, which in turn are organized into blocks. And if you see in the diagram, there are, what is that? 1, 2, 3, 4, 8 pages are in a block. And then these blocks are then organized into a plane, which is the brown rectangle. And then planes are grouped and organized into dies. So it's a nested structure. And I think one plane is 512 bytes, if I remember right. So that's how these data is handled in SSD instead of drive sectors and tracks in HDDs. So this method makes them more efficient, and obviously because data is written and erased by charge, which is basically if a plane has a charge, it's a 0, or it's a 1. If a plane doesn't have a charge, it's a 0. Instead of demagnetization and demagnetization, it's a more efficient way for the computer to interact with the hardware. But because it's being handled through charge, the way they've designed SSDs is that data is handled only in blocks, never in pages. So if a data needs to be added, it would take an entire block, but never a single page. It might be that the data is sufficient only to fill a single page, but even then, an entire block will be taken and never a single page. Um, I don't remember the exact description of it, but at a high level, it was basically that if the computer started changing the charts of every single page one by one, then it would accelerate the wear and tear of any hard disk. So your SSD would fail faster if it's done that way. So to expand the I guess longevity of the hard disk or the SSD, they started using block read, block writes instead of page read, page writes. So that's a quick introduction on how SSDs handles data. Right. So going back to the whole charge-based read and write. So when a block is selected for deletion, if you delete a file, that block is selected, it is marked for deletion, and essentially it's marked as a dirty block, and it is left for the garbage collector to collect. The main difference between this and HDD is, if you recall here, this data just, if it's a HDD, that data just kind of stays there. It doesn't really go anywhere, and there's no real process in place to remove that file automatically. It sits there until it's overwritten. But here, the difference is once this block is marked as dirty, a garbage collector function kicks off, and then within a minute or two, that block is empty, as in it is cleaned, deleted. So in terms of efficiency, yes, that's really good. But from a forensic investigation perspective, that would slow down progress of an investigation. Because if there's no data to be found, there's no evidence for you to collect and analyze. Obviously, that poses a bit of a problem. There has been advancements in this area, but it's still a very early stage situation where forensics with SSD is still a very daunting and difficult area that is still being researched on. I know there are a few companies that specialize on recovering data from SSDs, but it requires a lot of time and money and resources to actually be able to do that. I think they go at a hardware level and interface directly with the actual PCB itself, rather than being able to just recover data through imaging, which is what a forensic investigator would be looking to do, instead of having to mess with PCBs and potentially destroy the evidence, which is the last thing what any forensic investigator would want to do. Okay, so that's there. In SSDs, there's also a concept called over-provisioning. I haven't read too much, or sorry, I haven't seen a lot of information on this being shared externally. I was slightly surprised by the lack of information, but for any SSD, if you look at the file capacity or the capacity of the SSD, it would usually be in a slightly odd number. So instead of 256 GB, it would be 240 gigabytes of usable space. The remaining space would not really be something that is addressable by the OS. And when I say addressable, it means the operating system would not be able to read that remaining chunk of space, hard disk space, that in theory this SSD is supposed to have, because the hardware does actually support 256 gigabytes, but the accessible data or the accessible space is only 240, for example. And so this is called an over-provisioning issue. I guess you could call it an issue, whereas basically an overhead that is kept separate to make sure that the SSD doesn't accidentally overstore information. Again, it's a bit of a odd concept, because an operating system would only see how much space that the SSD tells it is there, but because of the way the SSD operates, there is a potential for it to overstore information. So they have this over provisioning available to avoid that issue entirely. It's not, again, it isn't addressable, but there are chances that data might be written onto that sector. From a forensic perspective, this over provisioning space could contain crucial information. It could also be recovered, because if the system doesn't know that data is actually stored there, it can't really tell somebody to go and delete it. So we could have full recoverable data in that section. The only problem is this is a hit or miss. And when I say hit or miss, it's not always that it's useful data. It might be like garbage information as far as your investigation is concerned, or it might be very crucial information that would lead to an actual valid evidence being brought forward. But it's dependent on the HD or on the SSD, and how the manufacturer designed the hardware, and obviously how they wrote the code for the firmware as well. So that's a quick overview on SSDs. Hopefully that made a lot more sense than what it felt like it did. But again, if you have any questions, do let me know. I'll try to answer your questions as best as possible. But if there's something I'm not sure, I'll check and I'll let you know. Next one is network forensics. Okay. Network forensics, yeah. So if you recall, I mentioned earlier, network forensics could kind of fall into two categories. So the first one is wireless forensics, which is more, your intranet investigation, where you capture packets, you investigate that, and then try to find out who did what and when. So that's wireless forensics. But it's also called network forensics, but network forensics could also refer to the infrastructure of an organization, where basically it's everything within the network. So your, let's say your network, your switches, your routers, your firewalls, your servers, your database, everything that sits within a network, your workstations, everything. Everything that sits within a network, you could also call it network forensics. The reason why I'm covering only wireless part of it under this section is because if you're looking at it from an infrastructure perspective, let's say you're looking at 200 servers within an organization. And if you've identified that 50 of those servers are infected with the malware, or 50 of those servers have backdoors installed on them, yes, you would be able to get information by looking at the data that they're sending outside. But if you want to get solid evidence from those servers, you would need to get access to those servers, image them, which is make a clone of that server's storage, and then go back to what is essentially your disk forensics. So it felt like a little bit of a redundant point to make, because at the end of the day, if you go down to it, it does end up becoming a disk forensics, or a local disk forensic, rather than a network level forensic that's being done. So for this slide, I'm focusing on the wireless aspect of it. So hope that's okay with everybody. And again, I've included a few popular tools that are used in network forensics. Wireshark, a lot of you may have heard about Wireshark, really powerful GUI-based packet capture and analyzer. If you run Wireshark on your local host on your machine, and if you're connected to a network, in theory, you should be able to capture every single piece of packet that is being sent through that network. So at the moment, if I run Wireshark on my machine, I would be able to see data from my phone, my TV, my PS5, anything that is connected to my local network. I would be able to see data packets from these devices being sent to and from my router. It's incredibly useful, especially if you're doing a proactive investigation, where you're actively looking at data being sent between devices or outside of devices. If you have suspicions that a device or a resource might be sending out unusual amounts of data, you could try and do that. And obviously, from a law enforcement perspective, I'm sure you can imagine how useful that would be if somebody's connected to I don't know, a free Wi-Fi somewhere on a mall, for example. Not just law enforcement, but I guess threat actors as well. You could be connected to a public Wi-Fi which hundreds of people are connected to. You could start gathering all that information, and depending on the encryption protocols used, you could steal a bunch of people's information, be it sensitive, be it not really sensitive information, but at the end of the day, it is still personal information that other people did not want you to have. So it's a very powerful tool. Again, depends on who uses it, but it is a tool, so it serves its purpose. TCP dump, it's similar to Wireshark, but again, similar to Autopsy and SleuthKit. It's kind of a GUI based, CLI based tools that are available, so it is available for both types of users. Some people may prefer GUI, some people prefer command line interface, so it really is up to the user preference. Splunk, it's a really good log aggregator, and when I say log aggregator, it's basically it's a small enough tool, it's a lightweight tool. You could throw a bunch of logs at it, and it would show you all of the logs, align them with proper timestamps and everything, and you'd be able to comb through that data and, well, get the information that you're looking for. Really good tool. I'm pretty sure there is a free version. There's also a professional version. I would recommend working around with the free version of Splunk just to get an idea. It's just a good tool to have, even if you're not super into forensics. It would, I guess, improve improve the way you work around logs in general. Burp Suite, I'm pretty sure it's the #1 choice of #1 proxy tool for any security testing or penetration testing or red teaming in some cases, testers. It's a proxy tool, which basically means you can keep that application in the middle, in between an application and a server, and you would capture every single piece of data that's being sent by the application to that server, modify it if you need to, and then send it to the server and see how the server reacts, and vice versa. Modify the data from the server, send it to the client to see how the client reacts. So you could use it to, well, troubleshoot an application essentially, because you'd be able to see the request and response sent by an application on the server. You would also be able to see how data is being handled, expose security vulnerabilities. So really powerful tool. Again, similar to Splunk, there is a free version available. It's again, it's a really good tool to just know your way around. I would definitely recommend downloading it, just giving it a quick look. It might look daunting, but once you get used to it, it's a pretty good tool. npcap, it's a command line interface. It's a packet capture library for Windows by the Nmap project. Nmap is Nmap is an application again, and as part of their project, they designed npcap, and it says what it does. It's a packet capture library. It's used to capture packets in any network that the system is connected to. Really versatile. Again, same as the others. Give it a spin. See what kind of use you can get out of it. If not all of them, then I would assume that you would get use out of at least one of them. They are very, very good tools. Most of them are free. Even if there's a paid version, the free version usually does give you the core functions, so you wouldn't really be missing out on too much, at least from a starting perspective. Network forensics. Sorry, I went on a bit long on the tool side of it, but let me go back to the actual definition and the forensic implications of network forensics. Monitoring and analysis of computer network traffic for the purposes of information gathering, legal evidence, or intrusion detection. When it comes to network forensics, obviously it is useful to find out what kind of data is being exfiltrated, what kind of traffic is in your current network, see how systems are behaving, see what kind of data is being sent out, and all that good stuff. But it could also be used for intrusion detection. Prevention is difficult with a network forensic tool, but detection, definitely. There's also intrusion detection and intrusion prevention systems, which are dedicated devices that organizations can put in place specifically to do that. But from an investigation perspective, yes, you could use some of these tools to identify if there is an unwanted threat actor trying to send data to any of your connected systems, try and see if they can get a backdoor or gain access over the computer. So the previous types of forensics that we've seen, they usually dealt with static analysis. So your disk would be, both of your disks, be it hard disk, SSDs, and also, sorry, I'm really sorry, I almost forgot. So we saw how HDDs and SSDs work. It's essentially the same concept with your floppy disks, your USB drives, and everything. It follows the same concept. It falls either under this category or this category. So it's either memory stored, waits until it's being overwritten, or memory is erased and is gone within a few minutes. That's why I haven't covered them here in specific. I just felt like these two were the core of disk forensics, so I wanted to cover these as much as possible before moving on to the other types. So I just wanted to give you a quick heads up on that as well. But just going back to network forensics, so far all we've done is looked at static analysis, which is you have data, you take a copy of it, you analyze that data. But for network forensics, it's more volatile, which means data keeps changing. Data could exist 1 second, it could be gone the next. So it's a very active, proactive type of assessment. Obviously, you would need to be familiar with different network protocols. You need to be your ISO model. You should be well aware of that. What layer these traffic is originating from. So you should have a good understanding of that. And obviously, it would be good to know what kind of protocols are commonly used and which ports these protocols are commonly used for. So everybody knows port 443 is HTTPS. I'm really sorry. Give me just a second. I just need to grab some water. Sorry about that. Yeah, so like I was saying, everybody knows port 443 is HTTPS. So if they look at a network capture and they see 443 traffic, then they know, okay, so data is being encrypted and sent through the traffic or sent through the network. And it's the same with a lot of common ports and protocols. But if you see an FTP, for example, an FTP protocol being used within a network when it really shouldn't be. And for those of you who don't know, FTP is file transfer protocol. The original FTP protocol is deprecated, which means it's out of support, it's insecure, shouldn't really be used if you're trying to send confidential or sensitive information across your internal network or outside your network. FTP can be easily captured, and whoever captured your information will be able to basically rebuild that data that you've sent. And if there's a man in the middle in your network, they would be able to recreate every single piece of data or information that you are sending out to your recipients without too much effort. So you really shouldn't be using that. So if you see FTP traffic, obviously you should be able to identify that, and I guess you would also be able to identify which system that's originating from. You should also be able to tell which system this packet is being sent to. So there's this kind of proactive approach that'll need to be taken when it comes to network forensics. It's a lot more interactive, if you will, as compared to disk forensics or even cloud forensics, for example, and we'll get to that in the next slide. But that is network forensics. As part of network forensics, this is not necessarily packet capture per se, but logging plays a very important role when it comes to network forensics, because yes, you're capturing data, yes, you're looking at live information being sent across, but that doesn't mean you're always looking at actively changing information. You could you do have the option of capturing a large amount of data over an extended period. So let's say you you activate Wireshark on your machine, you put it into a network, sit there for 3 hours, let it collect all the data, and then you go away separately, start looking through the data. At that stage, whatever information that you've gathered is static, it's not going to change, but that is information that you've gathered over the duration of 3 hours. So you would have logs, not logs, sorry, timestamps against that packet, or all of the packets that you've captured. But how would you verify if whatever timestamp that's on your packet capture is the same as what is actually in the organization? That's where logs come into play. Usually, a lot of organizations do have logging enabled. It not only captures user activity, it also captures your network devices, your servers, any kind of access that's being, I guess, given, or any type of access in general, really, or any action that's being taken. It's usually recorded somewhere, and organizations that have an information security management framework would usually send these logs to a log aggregator. I've called it Splunk here, but it depends on what SIEM a company might use, and they'll start reviewing the log, collecting the logs and reviewing them there for unusual activity. And if you're doing network forensics, it is crucial to get visibility of these logs so that you can match the timestamps from the logs to whatever timestamp you have on your network capture, so that you can compare them and see, yes, there was a large volume of data sent from this IP to the other IP at the specific time and date, and that matches with the log. And that would just help bolster your evidence that you're collecting, and it would also help, I guess, certify the validity of your evidence when you're presenting it to court. If they say, how do you know that this isn't wrong? And it's just taking data or taking timestamps from your machine, you could show these logs and say, this matches the timestamp from the data capture. And it's just a, they work together. It's a complementary function, if you will, for network forensics. There we go. Right. Again, I kind of touched up on IDS and IPS, but intrusion detection service and intrusion prevention service. They also have logs, so not just your firewall logs or your proxy logs. You could also have IDS, IPS logs, which again would just give you more information to work with. The more information you have, the better your chances of successfully submitting evidence as well, legal evidence for a justice system. So that is network forensics. Any questions so far? Or if we're okay, I can move on to the next section. I don't see any questions, I think. Okay, I will take that as a no, and I will proceed. As usual, if you have any questions, do let me know. Otherwise, I will keep proceeding. Next section is cloud forensics. This is potentially one of the most complex spaces in which digital forensics is carried out. The reason I say complex is not only because it's essentially a combination of every type that we've seen so far. It's your disk forensics, your network forensics, your malware, your memory, everything combined. So that, yes, that is there. That's kind of there with every other type of forensic investigation that a person would carry out. The complexity comes in with the next line. So if you look at the second part there, it says requires involvement of multiple cloud actors, so provider, consumer, and carrier. For those of you here who are not familiar with cloud concepts, so cloud processing, at a very high level, is basically not processing data at your own machine because your machine may not be powerful, you may not want to spend the resources of your machine, or you want to calculate large volumes of data, or you simply you want to use an application that is made available by a different cloud provider. So to get past all of this, Forensic tool government. Yeah, come on, sir. Give me just a minute. I will just finish that point. I'll get back to your question, if that's okay.
Yes.
Yeah. Yeah. So to get past that I guess to get to that requirement, you use a cloud model, which is basically not using your own computer resources. So using a remote server or computer that's not on your estate or your network, and offloading the processing or storage to that computer and getting the results. So it's basically you don't do any of the heavy lifting, nor your system will do any of the heavy lifting. It's more the remote system that is being managed and controlled by somebody else that is processing your request and giving you just the information. So from a user perspective, it's a very light, it's a resource light concept. And obviously, as everybody knows, basically everything works on cloud these days. Zoom works on cloud. The presentation that I made on today was on Google Slides, works on Google's cloud. There's in slide you would see I've called out the top 10 cloud providers, which is AWS, Azure. AWS is Amazon, Azure, Microsoft, Google Cloud, Dell, IBM Cloud, DigitalOcean, Alibaba, which is the Chinese giant from Alibaba.com, Salesforce, another massive one, Dropbox, Adobe Cloud, which is the red circle with the white lines thing. These are the top 10 cloud providers, and all of them provide various services, and everybody uses them. Twitter is based off of cloud, Reddit, Facebook, any popular application that we can think of in recent times pretty much uses cloud, because our systems don't need to do the heavy lifting. It's the remote system that's doing the heavy lifting, and we're just enjoying the benefits of it. And with that, let me just address the question that was raised here. Based on experience, can you say open source forensics tool is good, or you should go for premium? Kind of sure. I would definitely say open source tools are better. The reason I say that is because obviously, if you look at the tools that I mentioned earlier, NKs, Xways, really good tools. Like they are professional. They are like they're expensive, but they are used by like law enforcement and all of them. The reason they use that is because one, open source tools, at least from their perspective, is if they start using an open source tool, if something goes wrong with the tool, let's say if a module doesn't work properly, or if a library corrupts, and if a user isn't able to use it properly, they wouldn't be able to go to the provider and ask them for an immediate fix. But if you're paying money for a licensing, and if you're going to like a vendor, they would be able to, like they would be obligated to, because of service legal agreements or SLAs, they would be obligated to fix that because you've paid them to do that service or give that service to you. But that's the only reason that I would see that as being a good thing. But otherwise, you basically have not much control over well, the functionality. But when it comes to open source, and that's the beauty of it. If it's open source, then obviously there's a community behind it who would be able to contribute to the actual functionality, the actual code that's being used by thousands and millions of people. So for Autopsy, yes, it's an open source project, and that's been built completely by community and the actual SleuthKit dev team themselves. And they'd also be able to integrate any different functions that customers might or end users might want. Obviously, there's also the downside that it may not necessarily be something that they could do in their current stage, or it could be something as simple as, we can't implement this function because it's similar to something that a paid version of a forensic tool uses. So, like for example, they won't be able to use Ncase's case management tool, which is really good. Like you're able to build a full graph that shows the timeline of files that was accessed on the system. Autopsy does have a similar function, but it's nowhere as good as what is there in Ncase and Xways. So yes, open source tools definitely better. There are downsides, but there's a lot more freedom. But if you're looking for reliability and I guess immediate customer service and support, paid and licensed tools would be the way to go. It really depends on use cases. And that's, again, to iterate, that's basically why law enforcements use these premium tools, because they know that there's a service, there's a licensing agreement. If a problem does arise, they can reach out to a support team and they'd get a response almost immediately. So that's my view, sir. Hopefully that addresses your question. Okay, back to cloud forensics. Right. Right, to go back to the cloud forensics one, I kind of went through the whole concept of cloud. I know it was a very high-level concept, but I know a lot of the people in here are professors, and I have no doubt that you know more about cloud computing than I do. So hopefully that high-level explanation was sufficient enough. But let's move on to the forensic side of things. If you're looking for cloud forensics, and I'll get a little more into this when it comes to the actual, I guess, acquiring information and the actual crime scene itself. And this will make a lot more sense when we get to that part. But when it comes to data acquisition, which is basically if you've identified a system that's compromised or affected in any way, as an investigator, you want an exact copy of that image or of that disk, right? But cloud doesn't really allow for stop, freeze that server, give me a copy of it, because a lot of times, depending on the deployment model, it could be multi-tenant, which means more than one company or more than one user could be using that cloud instance, which means if you stop the server for one customer to get that customer's information, the other customer who has nothing to do with this investigation would also be affected, which is obviously something that a provider would never want. So AWS, if they have to stop their servers every time a forensic investigation happens, AWS would be at a tremendous loss. And I'm pretty sure Jeff Bezos would not be the richest man in the world, or second richest, I don't know, it keeps going back and forth. So that is a major, that plays a major role with cloud forensics. So servers keep updating. Again, it's multi-tenancy. There's multiple regions that's included for disaster recovery purposes. So with all of that, and obviously the deployment model itself, it is one of the most complex investigations that a person could do. And again, I'll go a bit more into detail on here. So looking at the third point, looking at the second point, requires the involvement of multiple cloud actors, so provider, consumer, and carrier. Let me start with the easier one first, consumer. You, me, anybody else who consumes a cloud service. So for example, if you use, actually, in fact, yeah, for Zoom, for example, now since you're consuming this stream through Zoom and I'm presenting this through Zoom, we are consumers of this cloud provided service. So that's that part. And the provider, obviously in this context, is Zoom itself, the company who are providing this SaaS solution to us free of charge, luckily enough, to consume. So they're the provider. Who is the carrier? A lot of the times, it's the internet service provider. The reason I've called it carrier is because a lot of the times, some of these big corporations like Amazon, Azure, they usually have contracts or agreements with providers or carriers to make sure that their service has a very high uptime. And when I say uptime, it means availability. So even if 10 Amazon servers go down, there should be 1,000 more that's still available to the users, and the carrier should have enough bandwidth to support those 1,000 servers streaming data to their users. So there's a few parties here that are involved. Obviously, there's a few more that I've left out. I'm pretty sure there was a cloud auditor, I believe. I didn't include that because in the documents that I've read, the cloud auditor, I haven't really gotten too much information off of that specific party cloud actor. So I've only focused on the core participants, so provider, consumer, and carrier. Moving on to the next point, data acquisition, which is again getting the actual evidence and the actual image of the hard disk from the server, and the actual forensic complexity of your actual investigation would depend on the cloud deployment model and the parties involved. So the parties involved, again, the three that I've mentioned above. But when I say cloud deployment model, it's private cloud, public cloud, hybrid cloud. Again, I'll glance over I'll glance over what these are, just because I know I know I'm talking to professors here who would already have a very good understanding of what a cloud model is, so I'm not going to repeat the same thing over and over. But a private cloud is basically it's a private cloud. It's yours, even though the data is being stored remotely. That hardware is yours. That cloud instance is yours. You are not sharing it with anybody else. So any data that's on that cloud is yours. So this essentially is, out of the three, this is the easiest deployment model to carry out forensic investigation against, because if you own the server and if you want forensic investigation carried against that server, you have to give us permission. That's basically it. You don't need law enforcement to come in, except for when your servers are in different jurisdiction. Jurisdiction means in a different legal coverage. So usually cloud instances come with, or cloud services have region pairs, which is basically two data centers in different locations. So for example, Ireland and UK, India and Germany, stuff like this. So even if India has catastrophic failure, so I don't know, something bad happens in India and all of the servers in India go down, the exact same data will be available in the Germany data center. So if they are the region pair, then the exact same data will be copied across both these data centers. And even if a catastrophic failure happens in India, Germany's data center would take over, and you'd be able to create another copy onto your main data center, which would again be back in India, and you could operate your service uninterrupted. But obviously, Indian laws, Indian legislation does not apply to Germany, and vice versa. Their laws and regulations wouldn't apply to India. So obviously, when it comes to forensics, you have to be very mindful of the different laws and regulations that each country imposes on data. Germany, for example, again, this is just for the sake of this conversation, to provide as an example, but Germany falls under European Union, which has the GDPR regulation, which is General Data Protection Regulation, which poses heavy emphasis on data protection, data consumption, data handling. And that may not necessarily translate into the Indian legislation when it comes to data protection. So it's just these points that will need to be kept in mind when working across jurisdictions. But other than that, private cloud, easier of the three, relatively speaking. Public cloud, more difficult. So a public cloud is basically a common cloud. So AWS or Amazon AWS, for example, it is a commonly provided service. So Amazon provides the AWS service to everybody, not just one organization, not just the other. It is available to anybody who wants to use it. But they make sure that they are instanced, so that if your data is being stored on server A, and if another person's data is being stored on server A as well, neither of you can access each other's data. So that data is segmented or segregated properly, so that even though it's on the same server, you won't be able to see each other's information. So again, data protection and data segregation, which is very important when it comes to cloud computing and cloud deployment models. And public cloud, it's basically that. And when I say multi-tenant, that's the exact scenario that I just described. One instance could have, or one VPC could have multiple tenants, but you wouldn't be able to access each other's information. From a efficiency perspective, that's great, but from a forensic perspective, that is not really good, because as I mentioned before, if you are I don't know, the subject of an investigation, and if the other person has nothing to do with it, if a forensic investigator wants to extract your information from that server, they won't be able to freeze that server because it would affect the other person. That's where the whole multi-region and disaster recovery comes into play. See if they have like a, I don't know, a parity server somewhere sitting somewhere which would copy all of your data over. So all of these factors will need to be taken into consideration. Hybrid model, it's a combination of the above two models. Or sorry, not the above two, my bad. That's an error on my part. A hybrid model would be a on-prem, and when I say on-prem, it's your server is physically located at your location, your organization's location, and you also use a cloud. So it could be a private cloud, it could be a public cloud, it doesn't matter, but it would be a combination of your standard, your server rack sitting in your server room, plus you also use a remote cloud model to store your data, store and process your data. Again, as you can imagine, having a server in your organization easier than private cloud because it is your server, it is your data, it is your equipment. If you want a forensic investigation could be carried out on that server, all you need to do is give permission to the investigator and they can go at it. But if it's in the cloud, then obviously at all the points that I discussed previously, with the multiple actors, with the deployment models, all of this comes into play along with jurisdiction, multi-tenancy. It muddies the water just a little bit more, and it adds to the complexity of the investigation itself. Yeah, that's cloud forensics. So it's basically digital forensics, but in the cloud. So that is cloud forensics. And these are some of the challenges that are faced during cloud investigation. I would have covered a lot of these in my previous slide, but just to have them separately highlighted. Jurisdiction and region pairs, like I mentioned earlier, data could be stored in different countries where one country's regulation may not necessarily apply for the other country. Vice versa applies as well. So if you're looking for data from both regions, then you'll need to work with the law enforcement from whichever region you're trying to get data from. Make sure you obey their rules and regulations. An important point that is sometimes not necessarily highlighted when it comes to computer investigation and digital forensics is, yes, the aim is to find out who did what and who the criminal is and all that, but you have to understand that you are not above the law. So obviously, if you do something that's illegal for the purpose of an investigation, you will definitely get into trouble. So same rules apply to everybody else. So that's just something that needs to be kept in mind. And also, obviously, when it comes to cloud providers, they may not want you to directly handling the servers or the actual data acquisition. So you'll have to make sure that whoever is handling the data, whoever is doing this, doing the data acquisition for you, they do it properly. You'll also need to make sure they follow, chain of command, handle the evidence properly, and all that good stuff. So that is also there. Different providers have different processes. One company might do it in one specific way. Another company might do it in another specific way. They may both be right, but obviously there will be differences in opinion when it comes to certain aspects, and that may not necessarily work well with with a few areas here and there. Lack of international collaboration. This more relevant to any country that may not necessarily have good relations with your country of origin. For example, the whole Russia-Ukraine thing that's going on. If an investigation needs the involvement of Russian and Ukrainian government to work together, that's not going to work well because obviously there's tensions already, and it's not likely that they'll be willing to cooperate with each other. So that might end up impacting your investigation. So that's also something that needs to be kept in mind. I've covered the other points already. Potential lack of forensic expertise. So if a cloud provider says, they'll do the whole data acquisition and everything. But if the person who's doing it doesn't have any forensic expertise, they might mishandle the evidence, which would mean that the data is altered, which again, going back to my initial slide, means your data gets thrown out of court, which means your investigation was pointless. Again, multi-tenancy, you could have multiple users who have data stored in that server. That could also cause multiple issues, not just to the server, but also to you, because you don't want to cross-contaminate your evidence with information from another tenant who has nothing to do with this case. It's also difficult to isolate a certain user's data if you're imaging a full disk, because you wouldn't be looking at it from an instance perspective, you'd be looking at it from a hardware perspective. So not logical separation, but you won't be looking at logical separation of that case. So it would be a little difficult if you're trying to actually go to the deleted information. Again, the next point kind of adds on to the previous point. Other than per CSP is a cloud service provider, you wouldn't really be able to link a specific file to a suspect. You'll have to rely heavily on logs and the monitoring capability that a cloud service provider might have in place. So that's some of the issues that investigators face when it comes to cloud forensics. Let me just check. Good. Open committee forums and cybersecurity texts are discussed. Yeah, I mean, there's let's see. I know there's a couple of red forums that are being used. Sir, I'll have to check on that and come back to you. I know I was talking to my manager about this, and he sent me a couple of good ones. But I can check that, and I can come back to you on that, sir. If that's okay. Mobile forensics. The last section, I guess, for the types of forensics that I'll be going through a little bit in detail, and the rest I'm kind of going to go at a high level, just so that we have enough time to cover the others, because there's a lot to cover, and I want to do a little bit on everything, just to make sure everybody has a good visibility of everything that I want to cover. But for forensics, right, as I mentioned before, mostly similar to the disk forensics that I mentioned earlier, specifically when it comes to mobile. More recently, a lot of phones use flash memory. They're faster, they're cheaper, they're more efficient, and obviously it's more compact, so it doesn't affect the size of the phone. So manufacturers start using flash memory on mobile devices. A few years ago, we used to get phones with micro SD card slots in them as well. Again, similar concept. But nowadays it's kind of dwindled, but there are still devices which use which provision SD card slots. So again, similar type of scenario where it's a flash memory, not many moving parts. There's an interface there's a middleware that acts as an interface between the OS and the actual hardware itself. There's no moving parts, so there's no real actuator arm that's moving around writing data. It's all done through charge. So no charge, 0, charge 1, and 1 means data is written, 0 not written. That's how that data is stored there. So I've gone through the SSD part. I've given hopefully a decent idea of how forensic investigation is done when it comes to SSDs and how the way SSD works impacts forensic investigation. But for mobile applications, they're a bit of a niche, not a niche, a bit of a curious technology, if you will, because any mobile device, even if you don't have any service that you're using there, if you have a SIM card on it, or even if you don't have a SIM card on it, unless you have your phone on airplane mode, it would constantly send out signals trying to look for a signal, like look for a service provider, so it can establish a full signal. Obviously, if you have your Wi-Fi, Bluetooth, and everything enabled, it will constantly be looking for a connection that it can make to its associated protocol. Which means, again, going back to the two critical points that I mentioned earlier, I'm really sorry. think I've just about taken up time. I'll give me 2 minutes. I'll finish this up and we can go for the break. So the 2 points that I mentioned earlier is any change that's made to a system, it will alter the memory, which means even if you get an SMS when you're trying to get a mobile device as an evidence, it would change the contents of the phone. So what you do is you put that in a Faraday bag. So if you look at the picture, that nice little black bag is a Faraday bag, which basically means it would prevent any signal from going in or out of that device, which means you have now successfully preserved the state of that device. So how you got it is how you will image it. So there's that. It's relatively cheap. It's part of every single investigator's toolkit. So it's just something that I wanted to highlight because it's not really something that is brought up in the other forensic assessments. Older Android phones, they're a bit easier to investigate. You could image them, start going through them, no problem. But more recently, operating systems have had options where you could encrypt the actual storage. So encryption at rest is implemented. That does make things a little bit more complicated, but if you have access to the actual PIN or password for the phone, makes it a lot easier. For iOS, for those of you who have had experience with iOS, you know that there is an iCloud backup that is done off the phone. If you can get access to that iCloud backup and the password, you don't even need to image anything. That is your image because that is the point in time backup that's made of the actual file system, and you can use that to you can put that through through autopsy and work away, and that's that. Yeah, it's relatively easy compared to the actual acquisition and imaging when it comes to other types of storage media. There's a few more, but I know that we are at 10:30. So, sir, if it's okay, we break for a quick 10-15 minute break, and then we can come back.
Yes, Sriram. We'll go for break and then we will continue. Thank you,
Okay.
Sriram. Actually, you have covered almost the detailed insight about the various forensic technology and tools, and given the detailed explanation on various hardware and software tools for forensic. And network forensic covered, cloud forensic covered, and even mobile forensic covered. I think almost you have covered everything. So thank you very much. We will again meet at 10:45. So thank you, participants, for your passionate listening. And the second, if you have any queries, you can make a note of it. We will discuss detailedly about your doubts and clarifications by next session. So thank you very much. We will meet again by 10:45.